Hey there, everyone, it's Alejandro, and welcome back for day 263 of me doing Daily LeetCode challenge. Trying to reach 1 year's worth of good contributions here on GitHub. So today is for April 5th, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode easy, problem 1863, sum of all subset XOR totals. The XOR total of an array is defined as the bitwise XOR of all its elements, or 0 if the array is empty. Of an array of all its elements. Okay, for example, the XOR total of the array 2, 5, 6 is 2 XOR 5 XOR 6. Given an array nums, return the sum of all XOR totals for every subset of nums. Oh, every single subset, really? So this has to be done as backtracking. Or return the sum of all XOR totals. Oh no, there's probably a trick to this. Although it's an easy, so I'm gonna, yeah, okay. Since it's an easy, it's probably gonna be backtrackable. That makes sense. It's just like, okay, tomorrow we might get like a LeetCode medium, which is like, you know, do this kind of intelligently. So first we'll do the backtrack solution, which will be acceptable for this easy probably. And then we'll see if we can do something a little more clever. I return the sum of all XOR totals. Yeah, so that'll be interesting, right? And it's interesting. It's subsets, not subarrays, right? Because you could easily probably do some prefix sum stuff just to get the XOR of any singular subarray. But this is subsets, which is pretty annoying. But it usually means with DP you can do things, right? Actually, yeah, this is probably very DPable. If not, because what I was thinking is like, if this was a subarrays problem, you could essentially do like, you know, prefix XORs. And so that way you could essentially get the XOR of any subarray from I to J in just O of one time, as long as you did the prefix XORing work. And then it's like, you know, there's up to n squared subarrays. In this case, since we're dealing with subsets, there's way more subsets than there are subarrays. But we can probably DP our way through, right? So very first thing we'll do is a backtrack clause, right? Forgive me for my throat. I will drink a little bit of water. Beautiful. Yeah. We really want to do all the cases from it. So yeah, you know what? I might just do something like this. Self.nums is equal to nums. And here we'll do def dp, self, and then index I. Nums is equal to self.nums, and is equal to length of nums. If I is greater or equal, here we'll put a cache decorator. And then we'll return 0, right? There's nothing you can do. Otherwise, here we'll say, case 1. Wait. We want the sum of everything, right? Wait, I gotta be a bit more careful. XOR totals. So I can XOR with every, no, we need to go through all the subsets, right? No. Let me think. I mean, for this problem, we can easily just backtrack our way through it. I mean, okay, let's just backtrack our way through it, right? Here we'll have def, here we'll have sorry. Or here we'll just have XOR is equal to 0. I is greater or equal to length of nums. Then res plus or equal to XOR total. Return. Otherwise we'll do case 1, include element at index I. Case 2, don't include element index I. Num is equal to nums of I. So here we'll just do XOR total, XOR equal to num, backtrack from I plus 1, XOR total, XOR equal to num. Undo the XOR, which can be done by XORing again. Here backtrack of I plus 1. right? And something like return res, and something like this should work, right? But it's just backtracking. It's inefficient. There's no like, you know, smartness. Ooh, okay. Oh, because I don't call backtrack of I. There we go. XOR total, so I can't access this. Okay, beauty. Then you know what? We shall make this a XOR total. I never understand how this stuff works. Okay, do I have to make res a self.res as well? I do. Beautiful, accepted. Let's submit. And there we go, bada bing, bada boom. Completion streak 263 days. Consistency is key. See ya tomorrow. Okay, so, okay, yeah, this is what I mean. There's a huge spike here at 0 ms, and I'm in this little standard deviation over here. So there's definitely probably a better way of going about this. So it's very likely that, you know, tomorrow we might get like, you know, a medium version of this thing or something where we're not given like, you know, nums of length is equal to 12, but maybe something like 1,000 for n squared or whatever. Yeah, 88% acceptance rate. Okay. So this is one thing. Right? So this is one possible way. Where we just have def backtrack as a helper function, which here we'll do this, beauty. So this is one possible solution. Backtrack solution O of let n equal length of nums of 2 to the n. Pretty much. Yeah. Here we'll just say yeah, that's fine. That's fine. Yeah, so how do we want to do this some more efficiently, right? The only problem is that here we're dealing with subsets and not subarrays. So really, the only thing I can think of that with subarrays, it would be very trivial with prefix XORs, but here, since we're dealing with subsets, really, it's going to come down to DP some way or another, right? I'm going to have to be able to do this with DP. I got to think. If I have the sum of all the XOR totals, can I still like XOR my way through things? Because I can't be XORing sums. Because it's not sum. If I wanted to do sum of sums is pretty straightforward. If I have the sum of all XOR totals from nums of I onwards, at nums of I can essentially either keep the element or not. I have the sum when I don't keep the element. But what is the sum when I do keep the elements? It's actually kind of interesting, right? It's interesting. It's subsets and not subarrays. Which, yeah, like it really only leaves DP pretty much. At least, like, you know, DP is great for subset problems. We want the sum. It's not a maximization problem though. That's the very interesting point. It's not a maximization problem. It's just weird. Because you gotta have XOR totals. Like, how do you do this non-backtracking? Oh, also, sorry, my flux. Let me just disable that real quick. How do you sum of all XOR totals? Right, because sum of sums I could definitely do with DP. I want to add index I with, basically I take the current result, add a number. Yeah. But here I'm dealing with XORs. It's like, how do I figure out how that XORing would have impacted things? Given array nums, return the sum of all XOR totals for every subset of nums. They should be counted multiple times. Cool. There are hints in case we need them. Because can I, if I have the sum of all XOR totals, right? I can't XOR the number with the sum, right? I'm dealing with subsets here. Like DP is good for aggregating, which summing is an aggregating function. But here's something like max would be more convenient. Here we want sum. Right, it's like case 1, case 2 is just like XOR with it or not. You can't XOR with a sum. I mean, we can self.nums is equal to nums. Get sum of all starting index nums of +1 onwards. Rest sum p of I +1. Now I have the sum of all the remaining elements. I mean, well, let's try, right? I do not think this is gonna work, but yeah, we might as well try. Yeah. Yeah, of course not. She's not even close. It's like when you integrate that into all the XORings. Yeah, I'm not sure yet. I'm actually kind of not sure. First of all, I'm not even sure if it's possible, but it might be, right? I mean, for the case of this LeetCode easy, but like yeah, like I didn't do a backtracking call that was too inefficient, right? And it only beats 17 ms. Like there's an obvious peak here, and there's an obvious peak here. Like, did people find a way to solve this in no event? Like, I'm trying to think, if you iterate, you know, the next number, with the current, yeah, if you have the current sum, it doesn't help you. How the heck do you use that information? The remaining sum. You need to, like for every single candidate of the summation, you need to have baked in num as an XORing candidate. I mean, this is just terrible. I mean, maybe if I yeah, I am at a yeah, I'm still in this zone though. Like I notice a huge peak. This could be like there just used to be less test cases back then, but even then, it's just a very minimal amount of test cases. There's gotta be a better way. It's just how do I use a sum and the fact that I need to bake in an XOR in there? Because I have to do some sort of aggregation minimum, right? Because if I'm just keeping track of everything, then I'm just basically doing backtracking. Like I'm essentially taking sum of A1, A2, AN, and have, want, given, X, want, sum, Like, how do I do this efficiently? Like, there's no manipulation here. I can't just factor out an XOR. Right, I don't have access to A1, A2, so on. I just have access to X and S. Right, is there like some kind of brute, like magic sorcery math that I can play around with this? Like, I can't take out the XORs, right? Like, how do I do this? I actually don't know how to do this with non-backtracking then, because this is just, I don't know, like, given just S, which is equal to this, how do I transform into this? Like, just given my X and S here. Like, I don't know how to rewrite this in terms of X and S. I'm gonna augment my brightness here. Yeah, it's just kind of weird. Because, like, I see a peak here, so it's like, I would think, like, there's a DP way. Am I just thinking about this in the wrong way? I can't. Like, I must have some form of aggregation. I can't just keep track of the max of stuff. It's just terrible. Right, like here in my backtrack, I have a clear distinction. Here I'm adding to res with an XOR total. Here I'm doing XOR X. But I'm XORing just a set of chosen numbers. Ah, man, I actually don't know. Like, if I XOR this all with X, like, this does not equal, like, this XORed with X or whatever. It doesn't work that way. Like, I'm basically, like, I'm converting these into completely different numbers. I can't take this sum and convert it to this with just X. Because the sum S is just a number. It's just a number. And it's subsets, not subarray, so there's no need to... Literally, I don't get it. Is backtracking the best way? How many hints are there? There's 2 hints in case I need them. I kind of want to reveal. I'm kind of stuck. Just, how do you do this? Sum of all XOR totals. For every subset of nums. Yeah, the nice thing about DP is choosing, right? So when you deal with something like max, you choose one of the 2 options. Here you're aggregating options. even things that are small get added. Like DP is good for optimization problems. I generally don't know how to do this non-DP wise, right? So yeah, like, you know, I guess, like, you know, if tomorrow I'm hit with a medium version of this, I guess I'll have to think about it. But like, yeah, for this problem, I generally can't think of a DP way of doing this. There probably is, just because it's like, you know, there's this peak here, but whoa, I did no, I do not want to look at wherever the heck that is. I did not see that. I just saw an OR. I saw a logical OR sign in there. I did not mean to click that. Okay, my bad. All right, now though, I'm thinking about OR sign. Why is OR sign important here? So there is a trick basically to this. It's just I'm not realizing it. Okay. Well. Okay. Logical OR sign. Why the heck was it a logical OR sign? Do you OR everything as you go? Because it's like, you might as well keep things as ones, because you're doing sums, but like in some of them it will be zeros, some of them will be ones. Doesn't make sense to me. Okay, yeah, I honestly, the O-Ven way, first of all, I accidentally clicked that. Otherwise, I wouldn't even be thinking about logical ORs. But yeah, I can't even think. So yeah, for now, we'll just give up on the DP idea. It's fine. We just got this as a LeetCode easy. I'm not sure how to do this in probably O-Ven time, right? Where n equals length of nums. I mean, yeah, for this LeetCode easy, backtracking is sufficient, right? Not necessarily efficient, but sufficient. Just because of constraints. It's just that, yeah, tomorrow we might get, like, you know, a harder version of this, and so I might, in fact, look after this, like, you know, is 1864 basically this but harder, and so on, and maybe I'll try to solve that in my own time and so on, so that way if it comes up tomorrow I'll be like prepared. But yeah, oh well. Yeah, it just feels a little sad because now I know there's a better way of doing it and I can't figure it out, but I'll just think about it off screen if anything. But there we go. So yeah, otherwise that's pretty much it. So nevertheless, as always on my videos, I do a quick recap as I was solve the problem. So this one, I had a tricky, it's tricky and I still don't know how to solve this problem efficiently. The first thing I noticed is, like, okay, here we're told to do subsets. If this was subarrays, it would probably be a lot simpler in that you could just do, like, you know, prefix XOR so that you can essentially find the XOR of any subarray in O of one time. And from then it's like, you know, there's only n squared subarrays, and so you just sum all the, for each single subarray in nums ij pairs, you can essentially in O of one time look up the XOR of that and, like, sum them all up, and so it'll be an n squared algorithm. Here this problem deals with subsets, and when it comes to subsets, you really only have, like, one option, which is dynamic programming, or if you don't care about caching and making things exponential, then just go to backtracking, right? In the case of this problem, like, you know, it's a LeetCode easy, the constraints are small enough that, okay, I can just resort to backtracking. So here essentially we want to return the sum of all XOR totals for every single subset of nums, right? A subset is not a subarray, right? It's like you can essentially look at the entire length of nums, and for each number be like, do I keep it, do I not, and so on, and just form any subset you want of nums, right? It doesn't have to be contiguous. And so usually DP or backtracking are great for this. I was trying to think of a way to do this in DP, but I couldn't figure out, like, you know, if you have, like, you know, a sum of all the elements from index I plus 1 onwards. How do you take the number at index I and somehow, like, you know, basically, like, this is the problem that I was dealing with, in case you're curious, and that I'm going to think about after the video. If I'm given, like, you know, a number x and a number s, where s is equal to a sum of a bunch of numbers, how can I essentially get, like, you know, a1 plus a2 plus an? How can I turn it into a1 XOR x, a2 XOR x, an XOR x? The problem here is I don't actually have access to a1, a2, an. I just have to access to the sum s, and I don't really know how to deal with that. It's something I'll have to think about later in the video. So I know there is an O of n solution, just because I accidentally clicked in the video over here, but looked away as fast as I possibly can. I saw one thing, which was a logical OR symbol, so that makes me a little bit curious, but I didn't figure out a way to do this more efficiently than just pure backtracking, which is exponential time. But for this LeetCode easy problem, it'll be okay, but maybe tomorrow we get, you know, the equivalent medium with higher constraints, so I'll probably see if I can do something after the video. But nevertheless, let's get into how I actually solve the problem for this one, though, which is just with brute force backtracking. So essentially, it's like, okay, you want the sum of every XOR total of every single subset of nums? Great, I'm going to loop over every single subset of nums, and for every single subset of nums, I'm going to have whatever its XOR total is, and I'm going to have a global variable self.res, which initially starts at 0, that I'm going to add the XOR total of every single subset in nums to. Right? So here I'm going to have, okay, self.nums is equal to nums. Self.res will be the sum, initially 0. Self.xor total will be the current XOR total of the current subarray we're looking at. Subset that we're looking at. So starting at 0, because, you know, 0 XOR anything is just that anything. And so and plus it tells us to return 0 if the array is empty. So convenient XOR total to begin from. And then I have a backtrack function, so we can see how this works. Essentially, this will start at an xi. Here we grab our self.nums. Okay, if I is greater or equal to the length of nums, that means it's like, okay, we chose an entire subset, right? For each index I from 0 to the end of nums, we essentially, for each number, we did the case where we include that number or we don't include that number in terms of the XOR total. So when we reach the base case, which is I greater or equal to length of nums, it's like, okay, we have a current XOR total. Let's add that to res, which is our sum of all the XOR totals, right? And from that point on, return, right? Otherwise, if we don't hit this if statement, that means we're not done, right? I is not greater or equal to length of nums. We can still choose, right? So here, let's grab that number. Num is equal to nums of I. And we have two possible cases that we can do, right? The very first case will be including this number in our current subset, right? So let's do it. So we'll take our self.xor total, and we're gonna XOR it by the current number, right? Because again, an XOR total is essentially the XOR of all the numbers in a specific subset. So here we're choosing to include num. So we're just gonna XOR our XOR total with this num. We're gonna backtrack from index I plus 1 onwards, and then actually do the backtracking part, which is undoing the XORing part that we did. And if you're not familiar with XOR, essentially, if you have, like, you know, some number z and you XOR it with x, then if you take this and XOR it with x again, then essentially this is the same thing as z XOR x equals, you know, z XOR x XOR x, x XOR x, anything XOR with itself is 0, which is z XOR 0, and anything XOR with 0 is just itself, so it's z, right? So if you had a number z and you XORed it with some number x, then you can essentially XOR it by that number x again in order to undo it, right? It's just that in this case, right, this will be our right, this is our self.xor total, and the x is our number, right? So here it's like, you know, we XORed it by num, so then we re-XOR it by num to undo the original XORing by num, right? But kind of like, you know, regular backtracking, right? Where it's like, here you append to a list, here you pop from a list, right? Kind of a thing. And then here it's like, okay, what about the case where we don't include the element at index I? Okay, so here we're not gonna XOR our XOR total by the current number. We're just gonna, you know, backtrack from index I plus 1, and here we don't need any undo steps because we didn't do any do step, right? We didn't XOR total by something, so we don't re-XOR it by something and so on. We just keep it as is, right? So here's the case where we include the element. Here's the case where we don't include the element. And in both cases, you know, we'll have added to result, you know, that total XOR total value. So then at the end, self.res will just be the sum of all XOR totals because we essentially, again, we just backtrack to go through every single subset in nums. For each of those, we'll just always keep track of what its current XOR total is. And for each of those subsets, we'll add that XOR total to self.res. So then self.res will finally be the sum of all XOR totals of all subsets inside of nums. And there we go, bada bing, bada boom. A very nice, but definitely inefficient solution. We can just submit here just one more time, just for the sake of Goodness gracious. And yeah, so here I noticed, there's a little bit of a peak here and so on. I'm guessing if I had to do this in DP, right, I can't figure out how to like, take a sum of the remaining elements and essentially like, fit in the XORing of that number with every single sub element that was used to sum. Yeah, so I couldn't figure that out, but I know there is a way and so on. But hey, for now, this was a LeetCode easy. The constraints are very small. Backtracking is legal, so you know what? There we go. It is all nice and handy dandy for this one. Although it wouldn't surprise me if tomorrow's problem is essentially this, just with harder constraints. But in advance, I will probably take a look at that myself just for fun. And yeah. But otherwise, that's pretty much it for this video. If you did find it useful and enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye bye.